This video we're going to discuss forming compound propositions with conjunction and disjunction. First off, what is conjunction? So, conjunction, this can be expressed with the connective and the way you usually visualize an and is using the water analogy, water valve, where you have here as the output and we have here some valve switches. So as you notice, the configuration here is series. So if both valves are closed, then the water cannot flow to the output. Even if we open the other one, say we open this one, still the water valve will not flow, or the water will not flow in the valve. How about if we open the other, this one, and we could see that the water will flow. However, the second switch or valve will hinder the output. So still, it will be false. For it to be true, then the requirement is both valves should be open. And when that happens, water can flow freely. And the output will become true. So that's a visualization for the conjunction. So it can be represented logically as P and Q. So this one is the symbol for the conjunction, while P and Q are the propositional variables. And the whole thing is the logical expression. So next, what is disjunction? And the keyword for this is usually or. And the visualization for the or is a parallel configuration. Say like this. Where you have the switch here and the other switch, and say the water is here. So in this configuration, if you turn on this one, then the water can flow freely. in the same manner, if you turn on the other one as well, then the water can flow freely. And it only takes at least one valve to be opened or to be activated for us to have a true output. And that is OR. So, as an exercise, let's form compound propositions from the following propositions from what we have last time. Say, in the first one, we have this pair. Davao is the capital of the Philippines. Or, today is Friday. So if we let this to be P, and today is Friday will be proposition Q, we could write a logical expression, say P or Q. And let's try to solve its truth value. Since we know that P, Davao is capital, is false. Or Q, we know that today is Friday, that is true. Since this OR, the result will be true. Second example. Say, if we partner these two, and this time let's use the AND conjunction. And say these are integers. So we could again represent this as P. The other one is Q. And we know that the first one, so we could represent this as P and Q. So the first one is true, while the second one is false. And the output will be false. Final example, say we have this all men are mortal, and we added a proposition, all women are kind. But this is a vague statement, so we're going to replace that. Say all women are immortal, say. So let's use the connective, say OR. And the same drill, let's make this a P or Q. And we know that P is true, and or Q, which is all women are immortal, and that is false, giving us still truth, because one is true, the first proposition. And with those examples, we can now come up with a definition for disjunction. Disjunction is false if and only if both statements are false. Otherwise, it is true. And we usually term this as OR. And the logical symbol, the logical expression is P or Q. And for the truth table, we have P, Q, and for the output, P or Q. And the question is, how many rows are we going to complete this with? Let's just say we have variables PQ. How many possibilities do we have? For P, this can be either true or false. Same situation with Q. This can be true or false. Therefore, there are basically two possibilities each. And the way we count that is there are 2 for the first variable multiplied by 2 for the second variable will give us 4 possibilities. And we could extend this further basically to many variables. Say there are P, Q, R up to n variables. So this would be 2 times 2 times 2 number of rows, n. So the formula for the number of rows is 2 raised to the n, where n being the number of propositional variables. So in this case, we have just 2 variables. So it's 2 squared, which is 4. So that is true, 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 false, false, true, and false, false. Enumerating all the possibilities of the truth values for the compound proposition. So with disjunction, this is true the moment that we have a truth, and it is false when both propositions are false. For the conjunction, this is only true if both statements are true. Otherwise, it's false, and we usually term it as AND. With the symbol logical expression P and Q. So for the truth table, we have P, Q, and with the same reasoning as before, we will have 4 rows in the truth table. Only that in this case, the conjunction is only true when both input propositions are true. Otherwise, it will be false. That's it.